Last video ever. Alright, you guys excited? I'm excited. I'm ready to answer some of your questions and help you get ready for the midterm. Or not midterm, you already did that. The final exam. It's crazy. It's already coming up. It's crazy. I'm sorry. That's what I do best. Okay, you know I'm crazy by now. This one, we talked about linear regression. Now we're going to talk about nonlinear regression, which is really just like, it's exactly as it sounds. It's not linear functions. The main two that we're going to be looking at is exponential and quadratic. So exponential is of this form. Quadratic is of this form. They're not always going to tell you what the data is, so you're going to kind of have to do some interpretation. Remember, exponential either continuously grows or it continuously decays. Quadratic kind of has a bounce back, so it may go up to some value and then it'll start going back down. So kind of think about the data points, and you can think about what model you actually have. Speaking of that, that means I'm actually going to go to model 3 real quick, or example 3. We're going to do this a little bit out of order, so sorry I'm going out of order from the notes. It'll never happen again. This is the last lesson. So, which model would best represent each set of data, linear, exponential, or quadratic? So it looks like with this one, with the data, it's following kind of this line, and I don't see it ever going back up. So this one, I would say, is exponential. Exponential. I spelled it wrong, but don't get mad. This one. So now see how this one, it kind of goes up, and then it starts wrapping back down. That one would be our quadratic. And then our last one here, it kind of just keeps going, if I were to try to draw a best fit, and it's going in like a straight line, so this is our linear, just like we were talking about in the last video. All right, other than that, let's do 3 of these, and then we'll be done. We're almost there. So determine the equation that best represents the data in each set. So think about the values. So I have 3, 9, 5, 11, 7, 8. So notice, all of the x values are always going up. I go to 9, then I go to 11, which is higher, then I go to 8, then I go to 2, then I go to negative 10. So probably this is going to be a quadratic. So I'll say that this is quadratic, which is of the form y equals ax squared plus bx plus c. So now, in Desmos, again, I'm going to do this all in Desmos because it's super easy to do in Desmos. So let's see, I'm going to add a table. So add table, x1, y1, so I'll put in all my values, 3, 9, 5, 11, 7, 8, 9, 2, 10, negative 10. So again, you can see that this is doing something that is kind of quadratic. It's doing something like that. It has a curve to it. So now, let's do our regression. So I have y1, so y1 and then the tilde, ax1 squared, press over so you can get off that, plus bx1. Anytime you type x, it needs to be x1, plus c. Then it gives us a quadratic where it tells us, you could get the residuals if you wanted. It tells us our r squared value, which is similar to our r value. Tells us what a is, tells us what c is, tells us what b is. So Desmos is just going to ask you to type in, or really pick, so it's multiple choice, pick what the equation is. So I'm just going to put those in. So that means y equals, a was negative 0.814 x squared, b was 8.203, so plus 8.203x, and then plus c, or in this case minus, so minus 8.799. That's it. That's the equation. That's what they're asking you to do. Cool. That's it. All right. Moving on then. So similarly, we're going to find the regression model for this data. So I have 3, 27. I have 5, 16, 7, 8, 9, 2, 10, 1. So looking at my graph, it could be quadratic, right? And we get a pretty decent y squared. But it looks like if we were to keep going, it could also go down. So you could make the argument that it's quadratic, but I'm going to do one just for you, because I know you want to see it. That is exponential. To me, I would see that. I don't really see it going back up or anything like that, so I would probably do a first guess of an exponential function. So in exponential, we have a times b to the x1. Right? So here, it doesn't as closely represent it. So if you were trying to actually analyze something, you may want to use a quadratic. But it depends on what you're doing. If you're doing something that's decaying over time, like something's dying over time, you know it has to be exponential. It's not going to like suddenly rejuvenate unless it's a salamander or something. So with that being said, that's it. And I'm just going to write my a and b values. So y equals, a is 75.29, and then times b, so times b. I usually like to put in parentheses just to make it for sure it's not with that. 717 to the x power. That would be your equation. That's it. All right, last one. Last one. Are you so excited? I'm so excited. Yes, last one. I don't know why I make so many weird voices. I'm sorry. It's just comes with the territory. It's what you get for enrolling in algebra 2. Just kidding. I'm glad you're here. All right. Determine the linear regression for the x values and log of y values. So this is a little bit weird. So notice it says linear regression, so it's telling us it's linear. So since it's linear, I have to use the mx plus b equation. That is our linear regression equation. Now it's saying log of y values, so instead of just doing the y values, I need to type in log of those values. So let's see if Apex will do that for us. I know I'm going to have mx1 plus b, so I'll go ahead and type it while I'm on that. So now I have 3, 5, 7, 9, 10. I was nice and I didn't change those x values, so log of 1. Cool, it did it. All right, then log of 9. Then log of 24. Then log of 60. Then log of 140. It's 140. All right. So looking at it, if I zoom in a little bit, we see we have a line best fit. That residual is below, that one's above, that one's above, that one's below, that one's pretty much on the line. So I wonder if it has any residual at all. Yeah, just barely. But we're pretty close. We're pretty good. So really that's it. You'll write the linear equation using the m and the b. Really the big thing that I wanted you to see here was notice it says log of the y values. So instead of just typing the y values, make sure you type in log of the y values. So read the questions very closely. They're going to try to trick you up like that. But here you're just going to do y equals mx plus b. So y equals m is 0.284 x plus b, which is, well, I shouldn't have done plus, but negative 0.684. That's it. All right. And that's all you guys got from me. If there's anything you guys need help with, please, please, please don't hesitate to ask. I'm always just an email away. If you want to set up any Zoom sessions, bring it on. Other than that, I want to miss you guys. Keep in touch. All right. Last time to saying bye. I'll see y'all soon.